The world is going faster.
Data is growing exponentially.
We need answers now.
How can AI help?
We need more data.
We need JGP.ai.
So as you go into this new kind of architecture, you will be confronted to technical debt. And I'd like to categorize technical debt in two ways. The historical technical debt, okay, this is based on the decisions that have occurred in the past and the obsolescence eventually that are not interested anymore. Okay, so let's say you decided to use Oracle 20 years ago and you stop paying for support after 5 years. Well, this is an example of decision in the past that conducted to obsolescence and is part of a technical debt. Sometimes, however, you've got less obvious technical debt that is made of conscious decisions. And this is because you want to control the scope of your project. You may imagine that at some point I wanted to get more information about something, or I wanted to add this feature to my application, but that will create a scope creep, and I don't want my project to derail. Okay, so to avoid that, I can decide that limit my creep, okay, my scope, and it will be a technical debt, and just stop it. Okay, stop there, and recognize that it's a bad decision in an absolute way, but in the context of this project, to limit scope creep or to control cost, I decide to make a technical debt decision. So it's not always bad, but it is extremely bad if you don't document it and don't keep track of it. Okay, you've got to make sure that if you make such a decisions, you can revisit them, or you understand why it happened before. Another key change in history was how deployment, or just the idea of distributing your work or your application, has changed. Back in the days, you had floppy disks you installed from 8 inches to 3.5 inches, and the idea at that time was to go through a very formal process. Not saying that it's not formal anymore, but at the end of the application. Okay, and I'd like to take this. I like this example of Microsoft Visual Basic, because this is one of the languages I started professionally working back in the 90s, and back there in 93, so distributing your application, which was not even calling deployment, it was distributing, was covered in the 25th chapter out of 25 chapters in the book. Okay, where of course I'm promoting my book here, really shameless plug. But more recently, in Spark in Action, I wanted to start the deployment of the application in chapter 5, and the actual deployment with all the technique for deploying it was in chapter 6 out of 17 chapters. Okay, so it's really early on. And this willingness to release early and frequently was one of the driver, or one of the consequences of the DevOps practice. So, talking about DevOps, where does it come from? Okay, I think my understanding is that really it comes from this very new idea from 1959 from Mizuno-san from the Tokyo Institute of Technology that defines the PDCA cycle. Okay, so you plan, you do, you check, you act, and you start over. Plan, do, check, act. Okay, so this is, and for me, when we go to DevOps, it's really about exactly the same thing at a faster pace. Okay, as fast as a sprint, as fast as a day, to release really quickly. Okay, so you've got your You plan, you code, you build, you test, you release, you deploy, you operate, you monitor, you plan, you code, and I'm losing my breath. But this is really the idea there. And I'd like to extend that to SAFe, to the scalable agile framework, where you've got this definition around DevOps, which are really CALMR. Okay, so that's how they do it. They define it. Where the C stands for really a culture of shared responsibility. It's not a boss dictating you. It's a leader eventually, and a group of a community of leaders that is actually sharing the responsibility. This is about collaboration. This is about organization. This is about risk tolerance and people tolerance. It's about self-serving infrastructure. It's about sharing knowledge, something which is really important to my heart. And it's about having this mindset of automating everything, which is the A, which is automate everything. It's pretty obvious, right? And then you've got this L, this lean flow, where you visualize and limit your work in progress. Okay, you don't want to have huge amount of work in progress. Only small batches of work, all small stories. It's always better to have 2 or 3 point stories than a big 13-point stories in your sprint. And I recognize I'm not defining a story. Okay, and the M, okay, it's measure everything, and it's really about not only, but logs are becoming your best friend. Okay, and you measure everything, you keep track of everything, you log everything, and the best thing of that is you can use Spark to run analytics on your new collected data. And finally, the R is the recovery. Okay, it's about you deploy, but you can go back. You can roll back quickly, or you can fix forward your application. So that's really this culture of not fire and forget, but this culture of being responsible collectively. To enable that, there is something that is called infrastructure as code. In the classic way, you would say something like, hey, give me 2 application servers, and give me a database servers, and give me this RAID feature for this application server, and then you would start procuring this thing. So you can see in this example, you could definitely see IBM and ask for nice X series, and they will be happy to do that. Now you've got to see Lenovo for X series, but and it's still a way to do it, and you may still have to do it in some ways. But when you're thinking about the cloud way, you will start with a Docker file and say, and your Docker file will define what you want to do and what the system is going to behave. Okay, and you can still see IBM because they'd love to sell you IBM Cloud. So, and this is where IT is once more confronted to accounting. Okay, so it's always the same debate between CAPEX, which is capital expenditure, versus OPEX, which is operational expenditure. When you buy your hardware, let's say I've got 100K of hardware for my project, then I've got to mobilize CapEx. Okay, I've got to pay this money, and this money will have to have some depreciation over 5 years. So the fiscal benefit of buying something will only be visible over a period of 5 years. Whereas when I'm spending money with OPEX, my money is the fiscal benefit of spending money is seen right away. Of course, companies don't like to spend money, but they have to. Okay, and that's really something that is also getting a big favor in favor of OPEX. So what does that mean actually? Infrastructure as code. It's really about defining your needs. I'm taking a file, YAML, JSON, whatever, and I'm starting to define my infrastructure. Let's say I want a load balancer, I want my application servers, I want my database cluster, and all that I'm writing that in a file, and then I'm giving it to this infrastructure this infrastructure as code tool that is going to transform my desires, my wildest desires, into physical or almost physical solutions. Okay, and this is tools like CloudFormation on AWS or Terraform that is available a bit wider, will help you do that. And it creates the environment, and it also creates the links between your servers. Okay, so all this network as code is also defined there. So I know that my load balancers know about my two application servers here, that my application servers know about my database, and I can also use this infrastructure as code to define my passwords. Okay. So I can say, and I'm defining rules about my passwords. I'm not putting my password in clear in the text there, in text files, but I'm defining rules, and I so that my database server knows about the application servers and naturally goes further. In this diagram, you see these little green clouds. The thing is, whether I need specific stuff like my application server, let's say I want to use Web3 application server, then I can use my custom rollout applications I want, or I can use cloud resources like here my load balancer, my database, which could be RDS or Postgres on the cloud, or I could use Confluent Kafka for my event streaming there. Okay, so that I could mix specific needs, real stuff I really need from my side, and leverage as well resources that are made available by the cloud provider. And there's no limit. Okay, the thing is, okay, I have my development environment, and then all of a sudden I can have my QA environment, and I can have my production environment based on the same file. Okay, and if I've got a really complex organization, I can even imagine having a fourth environment or a fifth. Okay, and all that based out of almost copy paste from my infrastructure doc. One of the great things as well about that is that I can have different versions of this infrastructure. So I can have my V1, my V2, and my V3, and I can roll back. Okay, and here you see that my current one is my V3, source controllable. I can add that to my source control. So it could be in GitHub as well. So I can revert, I can go back and have branches and all those things. So this innovation has been made available by the cloud, and by a specific version of the cloud. So let's go a little bit in history there. Okay, in the 70s, software was almost free. You buy the hardware, you get the software. In the 80s, you see the rise of the license. People like Oracle coming there, Informix, and Lotus, and all these people that are starting to sell software to you based on a license scheme. And in the 90s, open source came. Okay, so the Linux kernel was released in September 91, and it matures over time up to a point where company says, "Hey, I want open source. I don't want to pay for licenses anymore." And this is combined a bit with the rise of the internet in the 2000 with Google's IPO was in 2004, and at that point the rise of the internet combined to the development of open source in there's a direct correlation there, made it an interesting market for the cloud to come. And this is really, like I would say, in the late 2000s, early 2010s, that the cloud was really taking some growth. AWS was created in 2006, but Amazon.com was only fully migrated in 2010. SoftLayer was created before, but it was acquired by IBM and became IBM Cloud in 2013. A few names in between. The first version of Azure was released in February 2010. So it's really the 2010s that started to create this vision of the cloud. And the companies love that because it's only OpEx. Okay, if you remember from before, there's no CapEx, there's OpEx here. And a lot of these companies were offering open source free software via these platforms. Okay, and it was also interesting to note that it was open source. Open source was also complex because you've got to recompile, who's maintaining it, all the so companies like Red Hat came there. And when you combine this attitude with the cloud, this is where you see that there's really a match where I can combine my support for my open source with my infrastructure and do that with the cloud. And but as you recreated a vendor dependency, okay? And enterprises see that, didn't like that. And as much as they didn't want to pay for licenses and they didn't want to be locked down to a vendor, well, same thing happened with the cloud, where companies don't want to be locked down, okay? So they don't like to depend on one supplier. So, and with no possible interchangeability. So that's why in the 2015s or so, there was a rise of a more open cloud, okay? And this is where you start up seeing things like Dockers in 2013 appearing. The initial release of Kubernetes happened in 2014, and even OpenShift was created before. But when you think about Red Hat, which is embedded and built on top of Docker and Kubernetes, it was released in 2015. So the version 3, which is a major step forward for OpenShift. So it's really, when you look at the cloud, what is really important is you've got the providers, okay, AWS, Azure, IBM Cloud, Google Cloud Platform, or OVH Cloud, or many others. You've got also Alibaba, Oracle. So you've got your infrastructure provider. And you have now an open standard on which you can build your application in a more reliable way, where you can have Docker, okay, where defining your machine, you can have everything orchestrated by Kubernetes, and even things like functions, okay. So if you're into Lambda function or Azure functions or IBM functions, you can use the same thing with now things called Knative, which is part of this Kubernetes ecosystem. And all that, if you don't want to spend hours working on administrating Kubernetes, you can have things like OpenShift that can help you do a little bit of this, a little bit more, simplify a little bit this architecture. So this is where the cloud is becoming this new, even this nicer boost of openness.
Thank you for watching.
Get more by following JG Perrin on Twitter.
Check all talks on YouTube at jgp.ai/yt.